Hello, I'm MCToon. Welcome to today's debate. It is a Friday debate, and this one is between Leslie Rhorer and Flatzoid. Often it's me debating, but today it's like, no, he's not on screen yet. Hold on, I sent the link to Flatzoid. He hasn't joined yet, so if I it's all ready to show him, and then I didn't even. There we go. There is Leslie. How you doing, Leslie?
I'm doing quite well today. Thank you, Mike.
Awesome.
Staying out of the heat, or attempting to stay out of the heat here in South Texas.
That sounds toasty there, huh?
Oh, a bit.
Got it.
Ooh, we've got
hello.
Flatsoid coming in.
Hello,
Well,
Flatsoid.
Welcome, Flatsoid.
How's it good? Good to see you guys.
Your shirt says "Yo Flurfs."
Yeah, it does. You like it?
It's funny.
Yeah, because I open my show every night with Yo Flurfs. How's it going?
Oh, all right.
We yet to make Yo Flurfs cool.
Good luck with that then. So I'll do a real short so people know. I am a member on your Patreon.
Mm-hmm.
And one of the perks of being a member at the level I'm at is a monthly one-on-one. And this is that monthly one-on-one. So I appreciate that. And a special message to anybody on your chat. If you are letting me beat you in supporting Flatsoid, what's going on? Seriously, you can't let me beat you. You go support what you like. All right.
I like your shirt, by the way.
Thank you.
May the force mean momentum with you. Correct. That's the actual second law of momentum.
There's
second Newton's law.
There's no momentum in this.
No, there's no momentum. dv over dt. It's momentum. Force over ma. That's the actual derivative.
Oh my God.
I actually did a presentation on this, mate.
It's not, but, all right. Anyway, oh my gosh. This for reference. So the format is I'm just moderating. I'm giving my one-on-one to Leslie basically, and there's going to be a format. We figure out ahead of time. I'll cover it quick. It's in the description for my video. But there's three questions, three things that both of them are going to go over. They're going to define a pressure in a fluid. They're going to explain at a molecular level how pressure in a fluid works. And they're going to provide a quantitative predictive model for the varying pressure in the air. The format is both you guys will get a chance to introduce yourselves. Then Flatzoid gets 10 minutes to present on those three topics, followed by Leslie on those three topics. Then we go into a total of 4 rounds of this, where Flatzoid asks a question. You got about 2 minutes to ask that, and Leslie has five to answer. And then we flip that. Leslie has 2 minutes to ask a question, and Flatzoid has 5 minutes to answer. Of course, that's, like I said, 4 rounds of that, followed by a 20-minute open discussion and 30 minutes where I will take questions from both of the audiences. So if you want to ask a question to one of the other 2 people, I'm just going to begin scraping it from both chats. I have both of them up. So that's it for me. It's the introductions then are to Flatzoid. You got a few minutes to introduce yourself.
Yeah, well, I'm Flatsoid. If no one knows that, I don't know if you've been hiding under a rock, because I know MCToon's been speaking about me quite a few times on his channel. I got a YouTube channel. I don't know how will I say for 5 minutes who I am. I'm from South Africa, obviously. I'm a flat earther. And yeah, I'm writing a book at the moment. So hopefully MCToon will get that book when it's done, because I know he loves flat earth books.
Yes, definitely.
And it's good to actually see Leslie Rhorer because, yeah, I was always wondering how Leslie Rhorer actually looks. Now you remind me of Santa Claus. Epic beard, by the way. But yeah, that's about all I can say who I am. But yeah, I got a Flat Earth channel, and if you guys want to, just go ahead over there, and I do some presentations and live streams practically every single night. And that's about it. Yeah. Thanks for having me on.
Leslie, you keep it to less than 5 minutes in your introduction.
Oh,
but
yeah. Oh, yeah.
no evidence at this part.
No. Flatsoid, thank you very much. Glad you like the beard. I spent 2 or 3 days growing it. And obviously I'm not exactly young. I spent almost 5 years, about 50 years ago, studying physics. And then I decided instead to become an engineer. And so I've been an engineer ever since then. And about 5 or 6 months ago, I started to look into some of these flat earth videos and MCToon's channel and so forth and so on. And that's kind of brings us to today. There's not a whole lot more about it. So I'll yield the rest of my time.
Right. So we go right to Flatsoid. You have 10 minutes on the topic. I'll read one more time. Number 1, define pressure in a fluid. Number 2, explain at a molecular level how pressure in a fluid works. And 3, provide a quantitative predictive model for the varying pressure in air. I see you've started your screen share. Go whenever you start.
Yeah. Let's take a sip quickly. Okay. So you ready?
All right.
I hope it comes to 10 minutes because I just created this quickly before the stream. Okay. Define pressure in a fluid. That was the first criteria you wanted us to do. So what I did is, first I decided, let's define it by getting the definition. So fluid pressure, the noun for it is the pressure exerted by a fluid at any point inside it. The difference of pressure between two levels is determined by the product of the difference of height, the density, and the acceleration of freefall. Then I said, okay, we have to know the differences between fluids and liquids because we do get people that have false equivocations and they think because gas is based as a fluid, therefore it acts as a liquid. But that's false. They have two different variations in behavior of how we observe them to react with nature. So a fluid is a substance that lacks rigidity. It can flow from place to place and through holes or gaps in containers. Fluids also have viscosity or thickness. With a liquid is the state of matter of a substance at temperatures and pressures intermediate between those of its solid and gas forms. It has no definite form and assumes the shape of any container that it holds. However, if the container's volume is greater than the liquid does not expand to fill the whole space, as a gas does. Like solids and unlike gases, liquids are relatively incompressible. That is, squeezing them does not make them smaller in volume. Now I want to put some keywords that people have to take what we just read. Lacks rigidity. It can flow from place to place and through holes or gaps in containers. This would be considered for fluids like with gases. Now let's look with liquids. It intermediates between those of its solid and gas forms. So it intermediates between the two, defines which one moves where. And it has no definite form. It takes the shape of the container that holds it. So if you have a basin or a bucket or whatever, it holds that shape. Liquids do not expand to fill the whole space as a gas does. So it definitely is two different behaviors. Gas will fill the space, liquids do not. And it's just relatively incompressible. Okay, so I just placed them here again so we can see the differences so you know between the two. So if anyone wants to take a screenshot, then they know. Okay, now the phases of matter. You need to know the difference between solid, liquids, and gas. The solid holds the shape. It's a fixed volume. Okay, the liquid has a container, so it takes the shape of the container, there's free surface, and there's a fixed volume, so it if you put amount of water or liquid or whatever you put in there, it's not going to fill the container. It's going to lie at its given volume that filled. The gas will take the shape of the container, but it will disperse freely into that container. Now, explain at the molecular level how pressure in a fluid works. Well, this is very simple. Pressure in fluids is caused by the molecules or particles colliding with the walls of the container. So this means the gas is hitting everywhere in the walls of the container. You require the container for the pressure to exist because they need to hit into the container to have a collision. Now, a gas consists of molecules that move constantly in random motion. A gas molecule has what we call elastic collisions. It does not transfer any energy with the collisions, the container walls, or any other surface, including the gas molecules. The molecule with a collision in turn exerts a force on the surface. So the pressure exerted by the gas is equal to the total force exerted by the molecules on the particular area of the surface divided by the area. This would be the pressure by the force area. Okay, pressure equals force divided by area. Because we know this, if you have a wider area, the pressure is going to be less because it's distributed more. If you have a smaller area, the pressure is going to be more. That's why when you take a needle and you place a needle on, you're going to have more newtons than having, let's say, a brick trying to push a hole through. So provide a quantitative predictive model for the varying pressure in the air. So I just thought I'd start with some gas laws. We got Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, Dalton's law, and ideal gas law. The ideal gas law is actually just like Gay-Lussac's law. They actually work hand in hand together. So Boyle's law. Boyle's law states that at a fixed temperature, the volume of gas is inversely proportional to the pressure exerted by the gas. So pulling up the increase. So if you're going to have your pressure 1, you're going to have a volume 1, which is going to equal the pressure 2 with volume 2. So if you're going to change the pressure or the volume, it's going to be inversely proportional to the pressure or the volume, because you change it, it changes the volume. If you change the volume, it changes the pressure. Okay, Charles' law. Charles' law states that the volume of a gas equals a constant value multiplied by its temperature as measured in Kelvin. So if the temperature is going to rise, it's going to expand, and it's going to change the volume. So the temperature will change, and vice versa. Now we go to Gauss-Lussac's law. This is actually, like I said, it's actually based on the ideal gas law. It states that the pressure of a given mass of gas varies directly with the absolute temperature of the gas. So when the volume of the gas is kept constant. So if your gas is kept constant and you have a volume, it's going to keep it at that certain pressure and volume. Let's move to Avogadro's law. Avogadro's law states that the volume of a gas is directly proportional to the number of the moles of gas when the temperature and pressure are held constant too. So you have your first volume, which equals your number of moles, okay, which is then the second volume, which is the second number of moles. So this would explain why you have different different pressures with different volumes. Then we have Dalton's law. This is what your atmospheric pressure is based on, by the way, guys. Take note what those gases are. Yes, it's gas. Dalton's law is a partial pressure state that the total pressures exerted by a mixture of gases is the sum of the individual partial gases. So all these gases together make up the 14.7 psi that we call the atmosphere. Note that they are all gases and they all have their own pressures. Then it's the ideal gas law, just like I stated with Gay-Lussac's law, which is actually about the same. So I'm going through this so quickly because it's time. Okay, so provide a quantitative predictive model for varying pressure in the air. Very simple, actually. The higher the elevation, the less pressure due to more volume to fill, and less pressure and temperature. So what we see is with altitude, the volume is going to increase because you got further distances for the molecules to travel. And because you got less gas up there, you have less pressure, and less temperature, you have less pressure. So at the ground level, there's more to hit off of. So there's more collisions. There's more heat transfer thanks to like the sun going and giving radiation off the ground and whatever. We have what we call dynamic systems. So everything is working in a dynamic system. So to conclude, the atmosphere is gas and has to abide by gas law. Thus, containment is required. And just for showing everybody, atmospheric gases are gases located in Earth's atmosphere. These gases primarily include oxygen and nitrogen, blah, 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 the greenhouse gases, just to show you that if it's a gas, it has to abide by gas law. And I'll give the rest of my time.
Well, good. You had a minute and a half left.
Oh, that's not too bad.
All right. And we're on to Leslie's presentation.
Hello. So
same three things, 10 minutes.
yes. So Flatzoid, you didn't really define pressure at all in a fluid.
This isn't, Leslie, this isn't your time to respond to him, just to do your presentation. Yeah, you'll have that later.
All right. Okay. So the pressure in a fluid, and a fluid is, in generally speaking, it is either a liquid, a gas, or a plasma. And the pressure in a fluid is defined as, and I'm not going to give the expression unless somebody really wants it, but it's basically an expression involving the entropy of the fluid. And it does result in a particular force exerted over an area. At the molecular level, as you more or less showed, you have the individual molecules flying about in the fluid or in the gas or in the plasma, and they will have a particular mean velocity, and that mean velocity is going to create on any surface, okay, not on the container, on any surface within that fluid, it's going to produce a particular pressure, a particular stress per unit area. And that is, of course, as the velocity of the gas increases, the mean velocity of the gas increases, the pressure will increase. Also, as the density of the gas increases, the pressure will increase. And of course, as the kinetic energy of the molecules increase, say they're heavier molecules, you'll also increase the pressure that's observed. And finally, a predictive model. A predictive model means that you can determine, okay, from a certain set of circumstances, what is going on. All right, so I'm gonna share my screen here. And there we go. Share. All right, let me know when that is live.
Yep, we got it.
Great, okay. So let us first assume that these are not fluids, they're solids, okay? And so let's say that each one of these weighs 100 newtons. Each one of these discs weighs 100 newtons, as you see here, okay? Well, we've got 5 of them. So as we would expect, the force here applied to the floor is 500 newtons, all right? If we come to this level, then we're only applying 400 newtons on this disc, and then 300, 200, 100 newtons on below them. At the same time, in order for these not to be moving by Newton's third law, there has to be an equal amount of upward and downward force. So this unit, okay, has 300 newtons above it and 100 newtons on its own, pressing down with a force of 400 newtons. That means this disc down here is also pressing upwards with a force of 400 newtons. Otherwise, they'd be moving, and they are not. Now, this is true regardless of whether this is a solid, or if these are fluids or gases, or if they are a plasma. In order for this section, this region right here, not to move, there must be the same downward force from above as there is adding its own weight from below. All right. So the fact is then that as we go down, the pressure increases. Okay. And that pressure is always equal, or I should say the force is always equal to the weight of the objects above it. And for the pressure, we simply divide that weight by, of course, the surface area at the junction of the two. So whether this is, again, a fluid or several solids, then this has a higher pressure at this level, right here where I'm pointing, than at this level, for example. And so we see why and how the pressure increases as we go downward and decreases as we go upward. Now, the difference, as you mentioned, is the fact that the gases are quite compressible, while most solids and liquids are not very compressible. So in the case of, let's say, the ocean, as we move down the ocean, this is very much directly proportional to the depth. Okay. And so if you are at, let's say, 33 feet of seawater, it's going to be 1 atmosphere. At 66, it's going to be 2 atmospheres, and so forth and so on. In air, however, the air at the lower level is denser. So consequently, the air above it has a little bit less, or significantly less mass than the one below. All right. And that's it. I'll yield the rest.
Did you provide the quantitative predictive model?
Oh, well, okay. I mean, sorry, I guess I should have written it down. For a liquid, okay, the force, or the force per unit area, the pressure per unit area, is going to be directly proportional to the height of the fluid, or the depth that you are in the fluid, if you wish to put it that way. In air, however, it's going to be a logarithmic value. It's going to be the pressure is going to decrease not as the height, but as the logarithm of the height.
All right, is that it?
That's it.
All right. You want to stop the share?
I am. There we go.
All right. So we go to our 4 rounds. It'll be a total of 8 exchanges. Flatzoid, you have 2 minutes to ask a question, and then Leslie will have 5 to answer.
To ask a question. Okay. I want to say, how would you go and link your relationship on that model based that you are false equivocating a solid and a gas as the same behavioral patterns?
And let me know for sure when you're done, so that
Yeah, that's my question.
All right, go ahead, Leslie. 5 minutes.
I didn't understand the question. I'm sorry. Can you
Okay,
restate it?
I'll try and explain it somehow. How are you going to make your model to not have a false equivalence of solids and gases, because you are false equivocating gas and solid to work the same, because solids are bonded, gases are not. How are you going to make your model work on the same principle if they behave differently?
We simply measure the fact that it does. They do. I mean, the fact that they do not are not easily displaced is not relevant. Okay, so the solids are rather static and they don't move around readily, but that's irrelevant. The force that they apply is going to be exactly dependent upon the height of the object. And if it's a fluid, an incompressible object like a fluid, then it's going to be proportional to the height, just as in my my earlier, let me show here again. Where is the show? Well, that's right. In my earlier display there, I mean, as you increase the height, the pressure increases directly proportional to the height. That's true if it's solids, like your barbells stacked up, and it's true if you have a fluid in a glass or something. It's going to be, the pressure at the bottom is going to be proportional to the height. The difference with a gas or a plasma is that the because it's compressible, the lower layers have a higher density and so forth. The change in pressure is going to go, it's not going to be as fast as one goes higher up. One moves up in altitude. So as the difference between, let's say, the surface and 1 kilometer, there's a much greater change than there is between 1 kilometer and 2 kilometers. And that's simply because in the 1 kilometer above the surface, the gas is denser. So the weight of any given column at that distance is going to be greater. Nonetheless, it still does go down as one goes higher and higher and higher. And it's going to go down as the logarithm of the height.
All right, is that it?
That's it for that question, yes.
All right, you have up to 2 minutes to ask a question to Flatzoid.
All right. Clarification, does it have to be one question or may it be?
It could be a multi-part question.
There you go. Okay, because I had several things. So Flatsoid, please explain to me how, I mean, you sort of criticized mine about talking about solids, and then when you were explaining, pressure, you talked about bricks and needles, not about fluids. And you didn't offer a predictive model at all. All you did is say, well, it goes up. It goes up or it goes down. I guess that's qualitatively predictive. It's not quantitatively predictive. And you did not explain how or why the pressure increases as you go down, okay? Whether it's a fluid or whether it's a gas or whatever. You did not explain why the pressure goes down. Please explain that either in a different way than I did or agreeing with my model. That's all.
All right, Flatzoid, 5 minutes.
Okay. First of all, the needle and the brick was to try and explain how pressure works on a surface. It's got to do with the area. So because the area is small on the needle, it imparts more newtons. That was the whole thing. So it was in context of explaining how pressure is related to area. So yes, it is. I did explain to you why the pressure goes down when we raise in elevation based on the volume changing. I showed all the gas laws showing this, which validates that. And you can go and look and use things like the ideal gas law if you want to work out per area of how the pascals would work in that area. So if the volume is going to change, in other words, the volume will get wider, more larger, then it's going to take more for the gas to be able to fill. And because there's already less molecules up there, it has a less pressure. And because it has also cooled down with temperature, the pressure is also decreased. So the reason we have less pressure there is because the gas is just behaving based on gas behavior. There's more area to fill, so it's less likely to have a collision. And because it's also traveling slower now, thanks to it cooling down, thanks to temperature and the pressure changing, we have the pressure mediation, as I would like to say, where it gets lower as you go up. Now, the problem that you've been having, though, is you've been claiming false equivocation with a solid and a gas is the same thing. Like I said, gases are unbonded, solids are bonded. So you cannot use the two. If you want to take it as like a gas and you take your fingers, all your fingers are separate, you could say, okay? They're not webbed together. Now, with a solid, it would be your full hand. So it's a total false equivalence to say that. And yes, I did give a predictive model, just like I explained to you. What was the other thing? I think that was about it.
All right. Well, Flatzoid, you have 2 minutes to ask your question. This is the third of 8.
I want to ask, how do you weigh a gas?
That was quick.
Yeah.
All right.
Well, there are a number of ways to weigh a gas. Normally, you'd use a spring balance. So you take a gas and you collect it on the spring balance, just like you would anything else, and you measure the force, the downward force on that balance. That's the answer.
Cool. Thanks.
All right. Let's go quick. Leslie, you got 2
We
minutes.
we might need to do more than 4 rounds.
Yeah, if they don't fill up. But there is an open discussion, questions from the audience, so
yeah,
should be interesting there. All right, go ahead. Leslie, you have 2 minutes to ask.
Are you muted?
sorry about that. Given that you say it's predictive, then so what is the amount of force as one, let's say in the ocean, what is the amount of force if you're at, let's say, 100 meters, given your prediction?
All right, go ahead, Flatsoid.
Well, it will be based on what you measure with barometric measurements. As simple as that, because you use a barometer, which is the pressure hitting on the surface. And I just got to point out your last answer you gave, you would require containment to have that. So you don't measure a gas, you calculate its weight. So yeah, but yeah, the 100 meters would just equal to anything that we've seen around. Like I said, you use a barometer. Like I explained it that the reason we see it, but I'm not going to be able to give you 100 meters because I'm not the best at maths, as MCToon also knows. So I'll concede with that.
No, we need a number. If in order to be predictive, the fact that you say it predicts something, you have to give us a number, and it has nothing to do with the barometer at all. So,
oh yes, it does. How do you weigh your gas?
I
How do you
didn't- I
measure
didn't-
gas? How do you measure gas pressure? That's the same. You use a barometer, correct?
I didn't ask about gas. I said in the ocean. If you're in the ocean at
But we're
100
talking about-
meters, if you're in the ocean at 100 meters, what is the pressure?
But we're not talking about water, liquids. We're talking about gases. That's the whole debate topic.
No, the debate topic is fluids.
gas.
Is fluids.
Gases.
Mm.
Did you see MCToon's
Yeah,
topic?
fluids.
Yeah, with gases and fluids.
No.
Yeah.
All right, then okay. Then what is, if you're assuming then that the pressure at sea level is 1 atmosphere, what is the pressure at, let's say, 1 kilometer? Based upon your prediction.
I already gave you an answer for that. I can even go look it up on Google if you want to.
Wait a minute, you just said you made a prediction. What does that prediction say about the pressure at 1 kilometer?
I'm quickly getting it up for you. Above the surface. Let's see. Well, the water pressure would be 10 bar, as you put it, if it was under the water. But I don't want top of the ocean.
But none of that is from your predictive model. That's from you
So
looking at
100 meter above sea level, air is about approximately 990 millibars. So it decreased approximately 10 millibar. Altimeters are
Good.
based on these changes of atmospheric pressure and are used in aircraft by mountain climbers. There we go. So like I said, you can use a barometer and that's what you get. So they use the barometer and that's what they measured. Which
But
keeps
that's
with
not
my
based-
model where I explained you have lower pressure, the higher you go up. Did you have lower pressure when you went up? Yes, you did.
But that was not what you didn't predict that number. You went to Google for that number.
Yeah, because it's observational number. You go to 100 gets 10 millibars less, correct? But would that change if you have a difference in temperature?
You tell me, it's your model.
Based on gas behavior, that would be a yes. Ever so slightly,
No.
that would change. Yes, it does. You know, you can do this
Pressure-
yourself, even
pressure-
in your house where you are living now. If you change the temperatures, you'll see the pressure changes ever so slightly.
Not ever so slightly, no.
Are you sure about that?
I'm certain about that.
Okay.
Again,
Have you
there's
done
no-
it before? Have you done it before?
Many times, yes.
Can you have you got a barometer there?
No. No, I don't have one here. No.
How did you do it? Would you explain to us how you did that then?
In the laboratory, I did it many times.
Yeah, would you explain to
All
me
right,
how you did
that's
it?
time.
Okay.
All right, that was 4 of 8. Next is Flatsoid. You have 2 minutes to ask a question to Leslie.
Let's see. Oh yeah, he said entropy of a fluid is pressure. So I just want to point out, how can you explain entropy as being pressure?
All right, Leslie.
You'll have to give me a moment. First of all, that's not what I said.
I wrote
It's
it
the other,
down.
it's the other way around. But give me a moment. Hold on. I'll pull this up.
Are you pulling up what you said for reference?
Well, I'm pulling up the reference because I didn't want to go into the full definition, but I will now.
Okay. Well, while you do that,
Yes.
I will. I'll just remind people I'm capturing some questions, and if you're in Flatzoid's chat and you want to ask something to Leslie at the end there, tag me and I'll capture it and put it on the list. And
All right,
Earth is Life, yes, it does say Yoflurfs.
Yeah.
Yes, it does.
So I can read this out. Do you want me to actually put up the text?
You can just read it.
I'll read it. Okay. Pressure is defined as the derivative of the mean energy by volume under the action of constant entropy. So if it has to be under constant entropy, you can't be changing the entropy in order to be able to properly define it. Okay. Or as a derivative of the free internal energy by volume at a constant temperature. So you can talk about being constant temperature or constant entropy, but nonetheless, it's the derivative of the mean energy under the action of constant entropy. So that's the definition, or they're equivalent definitions, but that is the definition of pressure.
Would you be able to send me that link?
Yeah. Right now it's just an email if you want an actual link to it.
That's
I
fine.
can get it. I'll have to do it later. I mean, obviously I'll have to go searching for it.
Awesome. Yeah. Can I ask you another question based on that though?
All right, go ahead.
What is constant entropy?
Entropy is defined as the natural log of the number of quantum states available to a system. So basically, entropy is a measure of how probable a system is. So if a system has a very low probability then of existing, then it has a very low entropy. If the probability is 1, okay, or I'm sorry, 0, if the probability is well 0, then it is the base state, okay. As for example, as temperature goes up, then you get a more chaotic system, and it's more likely. An ordered system is less likely, and a chaotic system is more likely as it goes up. So as the entropy increases, then you have a system which is more likely to occur. So that is what entropy is. The probability. It's the probability that a system can exist.
The macrostates and the microstates. Yeah.
Uh,
But the problem is you said entropy, a constant entropy is the pressure. So I'm asking what's a constant entropy? That's what I'm asking, not what is entropy, what's constant entropy?
Well, it means that the state of the that the entropic state of the whatever you're talking about, of the fluid or whatever it is not changing. Okay, it's got to be constant in order to be able to talk about a constant pressure. Otherwise, if the entropy is changing, then the pressure is going to be changing. That's pretty simple.
Cool. So you'd agree that's onto a container wall though?
No, it has nothing to do with any container whatsoever. It doesn't require a container at all. Okay. And it says, I'll read it again. It's the derivative of the mean energy by volume under action.
Volume. There we go. Container. Thank you.
That's not a container.
What's volume?
That's time.
Okay.
Sure.
All right. Hey, they're getting better now. All right, Leslie, you got 2 minutes to ask.
Okay. Your statement was simply wrong. Talking about you kept talking about newtons. Newton is not pressure. And your analogy of the needle and the brick were simply incorrect. Perhaps you would like to restate them.
No, I stick by it.
hold
Newton's
on,
is definitely
hold on. Just that.
okay.
Leslie, you need to ask a question. So.
Oh, all right. Well,
I mean, asking him to restate something technically is a question, but that's not really,
okay.
What we're
Sure,
going at for.
So,
here.
All right. So if I have a brick, okay, and let's say it has a weight of 100 newtons, and let's say it has a 1/2 meter area. What is the pressure on the floor?
Okay, so what how much newtons? 100 newtons.
100 newtons. Yeah, it's a 100 Newton brick.
Okay. 100 Newton brick.
Yeah, and it has a 1/2 meter 1/2 meter area, surface area.
1/2 meter. Can we just say meter for
No,
just
let's
simple
do it
facts?
no,
Because
let's
it
do
will be 1/2 meter. Okay. And by the way, 1 Newton is 1 Pascal. So yes, it's an SI unit.
No,
It's
it is
pressure,
not.
mate.
No, it is not. It is not.
Okay, let me quickly work it up for you. That's my calculator. 100
Question
divided
asking
by
time is almost done.
100 divided by. Is it 0.5? Correct for meter. 1/2 meter.
1/2 meter. Yeah.
All right.
200.
Answer.
200 Newton.
The answer
It's
portion
200.
has begun.
So it's 200.
I mean, that's correct.
Mm.
All right.
Okay.
Well, hold on, wait a minute. 200 what? It's 200
Newtons.
what?
It'll be
Incorrect.
Pascal. It'll be a Pascal. 1 Pascal
no.
makes 1 Newton. Yes.
No.
It's pressure, mate.
No.
You just said it's correct. Now you're saying it's no.
Well, 200 is the right number, but it's not 200 newtons. That's
Pascal.
incorrect. No,
Pascals. What's it supposed to be then?
I asked the question. You need to answer it.
I told you, and you're saying it's incorrect. So what is the correct one if you're saying it's wrong?
If he answered the question, then right. I don't know.
Okay.
All right. Well, Flatzoid, your turn. This is number 7 of 9, or 7 of 8, if you want to be more precise. But I like 7 of 9. Doesn't everybody like 7 of 9? Give me a 1 in the chat if you like 7 of 9.
Yeah, absolutely.
But I have to say, I'm enjoying this.
Go ahead.
Okay, so since you say Newtons can't be Pascals, would you be able to bring me a citation up that shows that?
Sure. Easily.
All right. Go ahead. All right. Well.
Yep.
I don't. Just a second. I haven't seen. I've got a couple questions for Leslie, but just remember you can tag me and if you're in Flatzoid's chat, go ahead.
Can I quickly share my screen? It's like 2 seconds. It's fine.
Sure.
Yeah.
Sure. Share screen.
All right.
There we go.
Oh, hold on. Let me go back then. Hold on. That's correct. Okay. 1 Pascal. Actually, that's the same one I was going to bring up. It's 1 Newton of force. A Newton is a force, not a pressure. It's a force.
Pressure is the force over an area. That's what pressure is.
Well, but the answer is not a Newton. The answer is 1 Newton per square meter,
which is
or 200, which is Pascals. 200 newtons per square meters, but it's newtons per square meters. It's not newtons.
A Pascal.
And that is a Pascal. That is correct.
Thank you. Well, yeah, that was my question. I concede the rest.
All right, you concede. Good. You mean maybe a different word.
Stop the.
All right. The 8 of 8. Leslie, you have a question, 2-minute question for Flatzoid.
All right. You made the statement that it requires a container. All right. So, well, first of all, well, no, it's a question, so I'll just ask it as a question. So, all right, 1 second here. Let me share this. Okay, screen.
Just to say, correct, MCToon. Pressure is a force applied over an area.
Yeah, but they're not equal.
Correct. That's right.
No.
All right. Do you see that that little graphic there?
Yeah.
Chocolate? What?
Droplet.
Oh, droplet. That's correct. That droplet. All right. What container is containing that droplet?
It's still being held by the meniscus based on the surface tension by the dropper.
Okay. So what container is that? Or is that just a force that's containing it?
No.
Then what's
has
containing it?
surface tension. And as soon as that surface tension is given in, it's going to fall into the container at the bottom, the vial.
Well, but then that's not a container. Right now, it's not in any container. And if
You
you're-
are assuming that they aren't in containment with those containers.
It's not in a container. It's that simple. That's not
Prove
a
it.
container.
Prove it.
What is the container again?
How?
And if you say the force, if you say the force of the surface tension, that's fine.
All right.
Okay, it is held by a force.
It's
Go ahead.
Flatzoid's time to answer.
Go ahead.
Okay. You already assuming that they're not as a whole in containment. That guy holding the dropper with those vials are in a system, a contained system already. So if you want to ask, where's the container? There's your container. The water droplet is it's actually being held by surface tension, which requires a container for surface tension to exist anyway, because it needs the molecular bonds due to that dropper. And as soon as it falls, it's going to fall in the next container. So it's actually a mute question then.
All right. I take it you're done?
Let me stop that. Okay, I'll stop sharing.
All right. The now that wraps up the back and forth questions, and now we're just going to have 20 minutes of open discussion.
Awesome.
So keep it exchangey and not over talky, and I won't even have to be involved, hopefully. So, all right, go ahead.
Awesome. Can I start by asking you a question, Lizzie?
That's fine with me.
Okay. You say pressure doesn't require a containment. So when you specifically talk about gas pressure, would you be able to demonstrate us how you can have gas pressure without containment, without pointing to the sky? I mean, actual demonstration.
What do you mean by pointing to the sky? Yeah, I can show you. Hold on, let me pull it up. It'll only take a moment to pull it up.
I do appreciate that some people in Flatzoid's chat knows 7 of 9.
Oh, I have a friend who looks just like her. I swear, just like her.
But on a serious note, how long did it take you to grow that beard though?
Not really very long. I grow a beard rather quickly. When I was younger, I would wear a beard not quite this long, but almost this long. For participating in one play, and the next month I'd be without one, and the month after that I'd have a beard again.
Awesome. Yeah, because my wife doesn't let me go past 2 weeks. So it just gets bushy and then she says, take it off.
Oh, okay. Let's see here.
Like the fish tank in the back as well.
Oh, thank you.
He's going to be having sushi later.
I'm looking for a weather map. Here we go. Come on. All right, here we go.
Weather
So-
systems.
So yeah, let me show this. All right, let me share again. Share screen. All right. Okay, that's okay. You see that weather map?
Yeah.
Yeah.
You see where it says H? Those are high pressure. And where it says, well, I don't see an L, but there are high pressure areas, there are low pressure areas. There is no containment of those high and low pressure areas. They
It's not
simply
supposed to be.
exist.
It's not supposed to be. It's in the same system. That's why I said, can you demonstrate gas pressure out containment without pointing to the sky? And that's exactly what you're doing now. Going to weather systems that's got weather, the actual full system. I mean, it's in the same system. You are telling me that that's pressure without containment. That's
Yeah.
as a demonstrate. You're pointing to the sky, which I specifically asked if you please don't point to the sky.
What do you want me to point to?
I want you to demonstrate with an actual demonstration. Can you have gas pressure without containment? Because that's your guys' claim.
Yes, yes,
So can you show a demonstration of that?
yes, I can.
Okay.
And, it would take me a minute or a few minutes. I'm gonna try to do it here. Oh, here, let's try this. And first of all, your argument is beyond specious, because there are differing pressures right there, differing atmospheric pressures with no container. But here you go. Let me stop sharing this.
I stopped it already for you.
Oh, you stopped it. Okay. All right. Well, here you go. So you see that this is a piece of paper.
Mm-hmm.
What is causing that piece of paper to move?
You blowing pressure on it.
That's right. And there's no
And
container.
what's that paper? What's that paper?
What is the paper?
Is it a surface wall?
It's not a container.
Is that a surface wall? That paper.
It's a surface, but it's not a
Great.
container.
Okay.
There's a difference between a surface and a container.
So turn that paper, put it on your table, and take a droplet of water and put it on the paper. Is that paper going to contain the water?
Depends on how much water I put on.
So it contains them.
Mm,
Yes. The
No.
problem you have is you don't understand. Gas pressure requires a closed container.
No, it does not.
You making that claim, and yet you're not be able to demonstrate that. You just showed me a container, a surface wall, where you just showed that entropy will increase because as you
I just-
blew,
I
the
just showed you.
gas, the
I
gas
just
hit the
showed you-
paper and bounced off.
I just showed you a surface, and I just showed you there's pressure on it. It is not closed. Okay.
I know, but what
It is
happened to the
this-
gas? What happened to the gas? Did it disperse off of the surface?
Doesn't matter. It still produced a pressure on it.
It's exactly the argument. It disperses off of the. You can claim the Earth is an open system, correct? So you can say the surface of Earth is the container wall. It's an open system. That's what you can claim, correct?
No. The Earth is an open system, but no, it's not a container. The Earth is not a container.
Show me an open system that does not have a surface wall.
The universe.
No, show me a system that does not have a surface wall.
I can walk
You
outside.
can't. You
I can
can't
walk-
because
I
a
can walk outside.
system, a volume requires containment.
No, it doesn't. Here,
Yes, it does.
Here you go. No, here you go. Right here. Hold on. Here you go. No, it does not. I mean, you can say that all day long. It doesn't mean that it has any validity. It's simply wrong. So here, let me share this.
Yeah, what's volume?
A volume is a region of space.
And that region is based with a boundary.
No, not necessarily.
So volume doesn't have boundary.
No, not necessarily.
You're going against what volume means.
No, I'm not.
Yes, you are. Show me
I-
volume without a boundary.
Here, I showed you one earlier, but first let me
No,
show
you
you this.
didn't. You didn't.
Here,
You just
look.
you hand wave dismissing everything,
no, I'm
and you're
not.
just saying, I say it's this, so therefore, who cares what physics says?
Here, that is a volume. Okay, right there. It's a volume.
Yes, inside
Has no-
a
has no-
already
No,
Yeah,
it's
an
no,
arbitrary-
it is a volume by itself. That is a volume right there.
with an arbitrary boundary, just that you said
No,
didn't
not an
require.
doesn't have any boundaries. None at all.
That's exactly what you just showed with your hands. So then I can say the volume is past your hand boundary that you made. That's not actually a boundary.
No, it's not a boundary, which is just what I said, but it's still a volume. It's
Okay,
it's still about an eighth of a cubic meter.
Which is
That-
a
that is a what?
boundary.
No, it isn't.
You just said
That's
an eighth of a cubic meter. What's a cubic meter?
It's a volume.
So if I say, okay, I want a volume of 10 cubic meters, and you're saying, but there's no boundary, then how do you know it's 10 cubic meters?
Because we measure it. It's that simple. We measure it.
So a boundary, you got a arbitrary boundary to measure the 10 cubic meters. That's what
No.
volume is.
No, it's not. Simply
What-
is not. I mean,
what's a
you
cubic
can
meter?
see
What's a cubic meter then?
it is a volume of space whose
Length, width, and
About-
breadth, correct?
yeah, typically, yeah.
Which requires a boundary if you got a volume of
No,
something.
no, it doesn't. I
So
don't know
you
how,
s-
I can go out in the ocean, okay, and I can sit there and point and say, there is 1 cubic meter of water there. It doesn't have to have any boundaries at all.
That water is physical. Okay. You're giving a cubic meter. That would be an arbitrary boundary of the water,
It's
which is already
arbitrary.
in, which is already in the system.
It's arbitrary, but it's not a boundary. It's just an arbitrary measurement. And oops, hold on. Stop share. I clicked on the wrong thing. I'm sorry. So here we go. All right. So all right, you see my screen there?
Water balloon. Yeah.
Okay. All right, so that's a water balloon. All right, what boundary is there?
You just pop the boundary. Now
But
it's
it-
all accelerating at the same rate. Then the 0G plane, correct? And there's air inside that container. They are all in an aeroplane, which is a container.
No,
Yes. Was that water holding a balloon before they popped it?
the balloon was holding it, yes, before, but
So
not
that was a
after.
boundary. So that was the volume. And when they popped it,
It has the
you
same
see how-
volume. It
oh
has
look,
the
is
same
it
vo-
leave? It doesn't have
has
the same volume.
Yes, it,
Look at the
well, not
water.
even.
They're adding more, and some of it's leaving.
They're adding, yes. The point
So
is
the volume's not
Flatzoid.
the same. That volume's different to that volume, correct? And you understand in that plane, they have gas molecules hitting that water from all directions. Would that be correct?
Doesn't
So
matter.
that would be the
Doesn't-
arbitrary, that would be the
No.
arbitrary boundary it's sitting in.
No, that's not. It could be in a vacuum and that would do the same thing.
A vacuum, are you sure about that?
Yes, I'm sure.
Can you test it out for us?
It can be tested, yes. I don't have the materials to test it right now, but sure, it can be tested.
Has someone done it before?
In the vomit comet, I doubt it. In the space station, maybe, I don't know.
So no one's tested it then.
I just said, I don't know.
So then how can you make a positive claim about it if you don't know?
I said, no, I didn't say I don't know whether it would be true. I said, I know no one has tested it. And I don't know whether anybody has actually done that experiment or not. Doesn't mean I don't know the results of the experiment.
So then I
Certainly,
then
I have.
can I
uh,
share screen?
Sure, go ahead.
Okay, you'll just have
Sharing
to, yeah.
yours. Let's see.
There we go. There we go.
Okay. Share. The volume is simply defined as the amount of space occupied by any three-dimensional solid. The solids can be a cube, a cuboid, a cone, cylinder, well, that. But let's go here. Volume is defined as the space occupied within the boundaries of an object in three-dimensional space, which is length, breadth, and width. That would be a cubic, correct? So that's an arbitrary boundary. It's
I
on
mean,
screen for you right now.
Yeah, I see it on screen. It's an improper definition. I mean, you've got an improper definition there. A volume is just a
Improper,
region.
improper
volume-
definition.
Yes, it's an improper. I don't know where you got it from. What is that link? Where is that link from?
Flashlearn.com. They do it for children even. How about Byges.com? They also say volume in physics. Volume is a basic physical quantity. Volume is derived quantity expressed in three-dimensional extent of an object.
Yep.
An object has a boundary, correct?
No, incorrect.
Oh,
That's it.
really? Okay. This
No,
cup
it's
I'm holding in my hand. This cup I'm holding in my, oh, you can't see it now. This bottle I'm holding in my hand. Does this have a boundary?
Yes, it does. But just because some things have a boundary doesn't mean
That's a
that
physics.
they have to. No, does not mean that everything has to have a boundary. This is a mistake that you make, brother, continuously. Just because some things have some attribute does not mean that everything must have that attribute. A
It
volume
said
is a volume is merely an arbitrary
boundary.
area of. Just because you show a boundary means nothing.
Okay, let's put it this way. If you take your arbitrary cube squared, as you said, okay, and you say there's pressure in there, would that require boundary?
No, it does not.
What's pressure again?
Do you really want me to read that again?
But I'm telling you because you're contradicting what you said earlier. What is
No.
pressure?
No, I'm
Yes.
not. Nuh-uh.
That's exactly what
Yes,
you're doing.
that-
No.
No,
So
I'm not.
again, I'm going back to my first point. Can you demonstrate gas pressure without containment? Without pointing to the sky, actual demonstration.
I just did right here.
That is a container. I proved it
That
by
is
showing
not-
it on the table
that
and
is
sticking
not a-
water on it. It holds water.
That is not
Container.
that is not a container.
It's an open container. It's like taking a plate. This cup I got in my hand. This is a container, but does it hold gas? No, but it's a container. It holds liquid. Just like I explained with my presentation, the differences between liquid and gases. That's why I specifically brought it up.
Show
I've
me
just
show me where your definition of container is. All right.
Yeah, but let me first show you. This
No,
should be your paper. I'm just showing you, demonstrating there. It's containing the pen.
oh,
You
it
just
isn't.
said,
No, it isn't.
oh, is it not holding the pen up? Is it not containing the pen? What's
That's
it
not
doing then?
containing. That's not containing the pen. Merely applying a force to the pen.
There we go. Okay, I can't see anything now. It's literally
I can't hear you.
containing the pen.
We couldn't hear you when you were talking there.
Sorry, I'm just saying it's literally supporting this pen. It is containing this pen.
Support is not the same as contain. Contain means to restrain.
Yeah, and what's it restraining? Is it restraining this pen from going anywhere else?
No, it could roll off.
Okay. Still on. Seems to be containing it quite well. So you're just going to concede that a
Well,
surface.
okay, all right. Well then,
Single surface
okay,
can
well
be
then, all right. Well then, according to you, the surface of the Earth is containing the atmosphere.
According
nothing
to the
else
globe
in-
model, yeah. According to the globe
No,
model.
no, absolutely not. That's absolutely incorrect. According to you, the surface of the Earth is a container and it's containing it. So there doesn't need to be any other container other than the surface of the Earth, does there?
False. If your
You
Earth
just
is
said that.
considered,
You just
if your
said that.
Earth is, sorry, then you're false equivocating solids again with gases. That
Oh,
thing
I'm
does not contain gas because the gas hits it and bounces off. It disperses into the available volume.
No, it doesn't. There's
Same with
gas
your
on it
Earth.
right. There's gas on it right now. There's gas on it right now, and it's not
Okay.
going anywhere.
Gas is hitting and moving away constantly. That's happening, correct? That's not the same gas molecule staying here. It hits it and bounces off, correct?
Not in net. No. There's
Yes,
no,
it is.
No, not a. There's no net change.
Have you ever heard of
In
the
the-
Brownian motion?
Of course, I've heard of Brownian motion.
Great. So do gases static?
No, I mean,
No.
nothing is totally static, but that's beside the point. We need to stick on point. Okay.
That's
The
his
fact
point.
is that no, it isn't. The fact
It is. The gas hits the open the single open container, the single surface wall, and bounces straight off. It collides and goes the opposite direction. That is how gas
So
works.
does what? So does water.
No.
So does yes, it does.
Yeah, I'm
Yes,
gonna
it
put
does.
water on. I'm gonna put And then you tell me
Flatzoid,
if it's bouncing
Flatzoid,
off.
Flatzoid.
There.
Brownian motion was first
There we go.
observed in water.
There we go. I got liquid on here. Is it going off? Is it containing this liquid? Is the liquid bouncing off like gas?
Gas doesn't bounce. Gas doesn't bounce off either.
That's you going against what gas is.
No, I'm not.
You understand?
You simply do not. You have not defined at the molecular
Show
level.
me a
how it
static
works.
gas. Show me a static gas.
It's just. It's no more or less static than that water.
Show me a static gas.
Right here. If it's bouncing off there, how come this isn't going anywhere?
So you saying there's not 14.7 psi right now by you?
Are you saying that there's not 14 psi on that paper that you just plus some, that paper you just dropped water on?
Yes, but it's an open system inside a contained system.
No,
The difference is you don't have a contained system to make that claim.
We
Based on
don't-
based on the globe, it's an open system
no, it isn't.
adjacent to a vacuum.
No, it's not. No,
It's
isn't.
not.
No,
okay.
it's not.
Is it a closed system then? Is it a
It's
closed
not.
system?
It's not a closed system. No, but that's. It's
Then
not
what system
adjacent.
is it?
It's an open system.
So it is an
So
open
what?
system, which you just said
So
it isn't.
what? No, it's not adjacent to the vacuum.
Okay, so
Space is not
space is part of Earth's atmosphere then.
Okay, if you want.
Is that what you're saying? It's the same system. So we the center of the
Earth-
universe then.
No, Earth's atmosphere extends out well beyond the moon, but it's beside the point. We done?
That's the open discussion.
Yep.
I have now questions from
So-
the audience. So
Sure.
far, I've only got one for you, Flatzoid. So if you can,
Wow.
if your
That's a
chat,
miracle.
or sorry, one for Leslie. I mean,
Okay.
Oh,
So
okay.
if your chat wants to ask more for Leslie, then
Yeah, guys,
have-
ask
have them
ahead,
tag-
please.
Yeah.
Guys, ask questions for Leslie. Just tag MCToon for that, please.
All right. First question for you then, Flatzoid, is, and I'll start it now. There we go. We have 30 minutes for this, and then that'll be about it. I do have a hard stop, so I can't go too much later than that. Micah Ray says a question for Flatzoid. You say atmos is in Greek means air, but looking it up, it means vapor. Can you look up the definition of vapor? I find it means a substance suspended in air that is normally solid or liquid. Does that sound like atmos means air?
Atmos derived from the Greek word atmos. The atmo was derived from Greek word atmos. That's what it's derived from, which means air. If you go look at the definition for atmo now in the dictionary, that will bring up the noun for atmo as air.
But not from Greek? Doesn't mean
No,
the
it's
Greek word.
derived from Greek. It's just derived from. I'm not saying Greek is saying that is Greek's word. It's just derived from there.
All right. Professor Phil Bell asks, Flatzoid's model relies on volume. If you're standing on the ground, how is the entire volume of the atmosphere different than if you're standing on the top of Everest?
Easy. The top of Everest, you don't have trees and mountains and bricks and people and the surface to contend with. It's a much wider volume of space for the gas to hit off of. So less collisions.
But I think his point is he says that the entire container, as you've defined it,
Yeah.
is the same volume regardless of where you are. So how's the pressure different?
No, that's a straw man. I never said that.
You never
It
said.
goes against what I just said. I said it's a dynamic system, and therefore the volume which needs to fill changes based on gas behavior. So the higher you go up, the wider the area for the volume to fill, for the gas to fill. And because there's less higher up, because there's less collisions, less temperature, less pressure, therefore we see what we do, the pressure gradients. But this is still ignoring the actual argument, Jeffel. We require the containment for the pressure to exist.
All right. Leslie, question for you from Mum and Ryder. Show me weighing gas without a container.
Hmm?
That's for you, Leslie. Are you
I think he's muted.
are you muted?
Oh, sorry about that. Yes, I was muted.
Okay.
Yeah. I mute myself just so I won't interfere. I cannot think of an example where measuring the weight of the gas. Oh, wait a minute. Of course. Sorry, of course. A barometer does that. A barometer does nothing
It's
more
a
or less.
container.
A barometer does nothing more or less than measure the weight of the gas above it. And it does not contain the gas at all. Flatsoid, you continually say it's a container, it's a container, it's a container. That's nonsense.
All right. Back to got a few more for Leslie, but
Okay.
back to Flatsoid. Can Flatsoid explain the relative density disequilibrium works with satellite labs that are producing drugs in space using microgravity environments? Density alone does not seem to work.
First of all, he's making the question: is space and satellites there? Second of all, I don't think this argument is about relative density at the moment. We're talking about gas pressure. So yeah, maybe I can look into it because I've never heard about that argument before.
Okay. Back to you, Leslie. We've got
Yes, sir.
Michael Kahn says, Leslie, define elastic collisions.
Elastic collisions are defined as a dynamic system wherein all of the bodies collide with each other without any reduction in energy. They all maintain their same energy and also the same momentum, as opposed to an inelastic collision is where they lose energy. So, for example, say a lead ball hitting a piece of silly putty is an inelastic collision. It gives up energy to the silly putty. Whereas if you take a pair of steel balls and hit them, they don't lose appreciable amounts of energy.
Can I just give a statement on that quickly? Just if it's fine.
Yeah,
Just
go
to say,
ahead.
did you know gas has elastic collisions?
Yeah, we know that. That's obvious.
All right.
If they're, go ahead.
Question for Flatsoid. What's the definition of fluid? But you did cover that, and this is from Earth is Life. And then, so a second part of that, or related, I guess, is why can't the container that's supposedly containing the atmosphere around the Earth be detected by radar? And is it a solid container?
Well, it would have to be solid to actually be a physical boundary, I would say. But why it cannot be detected, I don't actually know. Sorry about that.
All right. We've got Level Up asks to Leslie. Ask Leslie if the atmosphere is uncontained next to the vacuum of space, please.
It's a malformed question.
Maybe you could rephrase the question and answer the properly formed one.
There's nothing. I mean, the only thing that's next to anything is one altitude is next to the next altitude up, and as you go further and further away from the Earth, it goes lower and lower and lower and lower and lower. So, I mean, if there's not a vacuum next to anything, it just gets a higher and higher and higher vacuum the further away you go.
Jiffy Cones asks Flatzoid, how does Flatzoid explain the existence of the atmospheric pressure gradient without gravity? He said more space. His magic dome is bigger at the bottom than at the top, is it not?
You got more collisions at the bottom. You got surface, and that's where the gas is usually distributed, you could say. And because you got more of temperature inversions and collisions, therefore you have more pressure at the bottom. That's usually how it works.
So there's more collisions at the bottom because there's more collisions at the bottom?
Because there's more of the stuff to hit. And the temperatures change dramatically. We live in a dynamic system.
Yeah,
That's why we have weather systems. I don't know how else to explain it as a quick way. But I mean, in my presentation, I already explained that. You can go look at Avogadro's law if he wants to figure that out.
All right. Wisecoff has a question for Leslie. How do whales communicate over 10,000 miles on a sphere? Whales demolish the radius. No ionosphere for an excuse.
Talking about the whales in the ionosphere is nonsense. The answer is that there are deep ocean channels which carry their sound and can carry that sound over hundreds of kilometers, although it's now much more limited because of all the noise. But nonetheless, it has to do with the conductivity of water for sound. I mean, the water is much more conductive of sound than air is. And because of it, it can go much further in water than it can in air. Simple enough. Has nothing to do with anything in the atmosphere, since it's carried entirely in the water. The whale sign is carried entirely in the water.
I'm gonna mispronounce this because it didn't come through right, but something like Bartholomew Muncha says, I have a question for Flatzoid. If I apply a force of 2 newtons to a surface of 1 square meter at an angle of 45 degrees, what pressure do I exert on that surface?
Do I have to go and work that out now as well?
How would you work that out? Maybe rather than just doing the outputting the numbers, what would be the process?
Don't know with an angle. Never tried that before. Would probably make a difference because it's not going straight down. So I wouldn't be able to know because I haven't tried to work it out that way, to be honest.
All right.
First time I've got such a question. I'll actually look that up, by the way.
Yeah, that's often that type of stuff's often questions on tests in physics classes. PJ Crookshank says, how can he say gas is static? Surely you know there's bouncing off that paper in all directions. Do you measure the weight of gas or calculate it? There's kind of 2 things in there. I think the first part wasn't much of a question, but you could address that, and then the second part is, do you measure the weight of gas or calculate it?
Is that for me?
Yes.
Okay. Well, you can do both, of course. You can measure it and you can calculate it. And the point being that for every molecule that bounces off of the paper, it's being replaced by another molecule. I don't know exactly how to answer that question per se, but yeah, you can measure it easily enough, and you can simply evacuate the area above it and find out that has measured the difference in weight between the evacuated area and with it not evacuated. Paper wouldn't be a good thing because of course it would tear too easily, but you can do it on a piece of metal easily enough and you can calculate it. The bottom line is, though, that every one of those molecules are no different than a baseball or anything else. They're much smaller, but they're no different in the way that they act. They all act under the same forces that act on a baseball. And the fact is that if those molecules are not traveling fast enough, there's no way for them to leave the earth, and so they don't. If they're that they, like anything else, you throw a baseball up, it's going to come back down eventually. You throw a gas molecule up, assuming it doesn't hit others along the way, it's going to come back down.
Can I maybe just give a rebuttal to that if you don't mind. If you don't mind.
Yeah, go on.
Gas has no ability to do anything on the direction of gas. Of gravity has no direction on the direction of gas.
That's simply false. I mean, it's completely false.
By the way,
Again,
because
the gas particles are no different from any other particle. They are just the same as every other particle.
you even said earlier gas has elastic collisions. It can only change direction with a collision. Only with a collision.
No, that's false. That's
Or unless you
false.
can get it to 0 Kelvin. Can you get it to 0 Kelvin?
I mean,
No.
it's just false. I mean,
It's not
you want
false.
to talk about a slingshot maneuver?
Gas
works
is not
just
a
the same
solid.
way as a slingshot maneuver around
Gas-
a celestial body. Works the same way.
No, again, gravity is not a force, and gravity, even down here on Earth, does not do anything to the
And-
direction of gas. And I can show you someone
Is Flatzoid
stating this
muted?
in physics.
Or am I muted?
He's still there.
No, yeah, we're still both talking.
I'm suddenly muted or something.
No, we can
Or,
hear you.
hang on.
We hear you.
Because I can quickly play a very short clip of a video I did if you want to, where I have someone actually saying this. Saying if you want to, but I know you'd have time because I know you don't really have time.
Yeah, I got to mow the lawn.
And I got to sleep. It's 1 a.m.
And then and then guess what? We're watching the Star Wars holiday special.
Oh, wow.
That's terrible. It's torture.
I think you like me. You like the old Star Wars better than the new Star Wars.
Oh yes.
Yeah.
Empire is the best easily.
Yeah, the new one, I think they cater to
There
the
we go.
younger audience and they have a different taste than us.
Okay, sorry about that, guys. This PC is very sick, and it just out of nowhere just suddenly muted my headphones. So I'm back.
Kin. Don't talk like that. Somebody was dissing you, Flatzoid, and
That's fine. I'm
they-
used to
they
it.
got- they got,
I just realized I've
somebody-
grown thick skin over the years with this.
Oh yeah, you have to.
So
All right. What were you? I totally forgot where we were at. Were you
I'm sorry.
answering something? Or
It was just about the elastic collisions, but
yeah,
it's fine.
yeah,
we
the
can move on.
elastic lid. Yeah, then he's like
Yeah.
he didn't hear. All right, well let's move forward then. Vadim asks Flatzoid, is a string restraining a pen a container as well?
No, that's a false equivalence.
It's just a question. There's no assertion.
Yeah, man,
so
it's a
there's no
false
fallacy.
equivalence.
There's no fallacy
a-
in it. It's just asking a
Yeah, but
question.
you see, a container contains it by the pen having a force on the surface. So a string is not the pen having a force on the surface of a string. The surface is holding it. So it's a false equivalence.
Right. Moomin Rider says, Leslie, I said show me weighing gas without a container. I didn't ask to show pressure. By the way, it's Moomin Rider, not Moomin Rider. I pronounced it wrong before. All right, Leslie.
Muted again.
Oh, he's not muted.
Yeah, it doesn't show the side.
Yeah.
It's on his side. I don't know. Maybe he's having
Sorry.
issues with his audio.
Atmospheric pressure at any altitude is equal to the weight of gas per unit area above it. So simply measure the pressure and multiply by the area, and you have the weight.
All right.
I mean, you could also. I'm
Oh.
sorry. Go ahead.
For Flatzoid, Wizard of Oops says, If you claim the paper is a container for breath blowing on it, why do you also claim Earth's surface is not a container for the atmosphere?
Never claimed the Earth's surface is not a container. I'm specifically fighting for it as an open container, as the heliocentric model claims it to be. If it's an open system, the problem is you do not have containment for gas to be held down in it. So therefore, you need the containment to have the gas pressure, because by definition of gas pressure, it needs to be exerting pressure on the container walls. Now, if it's exerting pressure on the container wall, would be the surface, and it has elastic collisions and can only change direction with a collision. It will hit the surface and bounce off into the surrounding system, which would be space.
Flatzoid, that's totally false. I read you the definition. There's nowhere in that definition about any surface whatsoever. Secondly, it is simply false that an elastic collision has anything to do with an elastic collision is not the only way to change the momentum of a particle. You change the momentum of a particle by applying a force. And it can be a collision between two objects. That's one force. It could be electrostatics. It can be magnetic forces. Magnetic forces can certainly be used to increase or decrease gas pressure if the particles are ionized. So
which is a different phase. So it's a different phase. It's not gas.
No,
anymore.
it's not. No, it's not a different phase.
Ionized gas is a different phase.
No, it's not.
It's not gas. Yes, it is.
No,
and
it
by the
isn't.
way, can you read this quickly? What does this say? What does that say for you?
Force per area, but that's not a definition. I gave you.
Yes, it is. Okay, let's get another one for
I
you.
gave you the. No, I gave you the definition.
Okay, I'm gonna get you another one. I've got
Probably
all
not
there, mate.
because. Probably
Pressure.
not because.
What is pressure? It's a force exerted on the substance per unit area on another substance. So that's physicality. The pressure of a gas is the force exerted on the gas of the walls of its container.
So
Mate,
it's wrong. I mean, I can show you all sorts of things coming from the internet that are just wrong. That's simply wrong.
Oh, so NASA's also wrong to you. Okay, congratulations. Gas pressure, BBC. What is gas pressure? The particles of a gas collide with the walls of their container. Okay, like I said,
But it doesn't require that they be a container. Okay,
Yes,
it doesn't
it
have to be a
does.
container. No, it does not. It can simply be a sheet of paper. And if you want to call everything a container, then as we said, then the surface of the earth is container and it doesn't need any other container. Either it is or it isn't. Either the surface is or isn't a container. If it's a container, then it doesn't need any other container. Fact is, the only thing that causes a gas to have a differential in pressure is gravity. There's no other explanation. There's no other explanation.
I got on
Only
screen
gravity.
all of this for you. I got this on screen for you. How much
see it
more? How much more must I go for you? What is gas pressure definition? I can go on, mate. This is chemistry talk. What is gas pressure from Chem Talk? It's the force on a surface area.
That's right. It
Okay?
doesn't say anything about
These are all the gas laws.
Do you realize?
the
First
gas
of all, first of all, apparently you don't realize all of the gas laws are only approximations. None of them are accurate.
Oh, really?
They are. That's yes.
Tell that to people that build car engines.
They know it already. I know that.
I'm sorry. If you need to know how much pressure is in cylinder one, it's quite accurate, mate. You cannot you cannot set your computer without knowing the exact amount of pressure in there.
No, that's completely incorrect.
No, it's
not. The fact that all of the gas laws depend upon talking about an ideal gas. There is no such thing as an ideal gas.
Ideal gas law is ideal gas.
All gas laws.
Hold on. Flatsoid. Ideal gas law is doesn't help you.
It's for ideal. Ideal gas law is for ideal.
Right,
but like I said, I can bring.
We gotta move on.
I think I made my point.
That one got old. Moomin Rider asks Leslie, anticipating your non-answer. Oh, well, this isn't even a question. What? Anyway, remember you said you weigh gas with a spring. Show me that without using a container.
well, you have to have an evacuated container. The gas doesn't have to be in a container. You can use an evacuated container and measure the amount of strain on the evacuated container. It doesn't require that the gas be in the container. But again, just because something is required to measure something doesn't mean that it requires that thing to exist. Okay, just because, you know, I have to have a container to measure water doesn't mean that water doesn't have a volume. It does have a volume. I have to put it into a container in order to measure a volume, but there's a difference between measurement and existence.
Question from Vadim says, can you ask Flatzoid to read the definition of atmospheric pressure?
Sure. Just note, atmospheric pressure has bylaws like Dalton's law. Just have to point that out. The pressure exerted on the weight of the atmosphere, which is at sea level, has a mean value of 101 pascals, roughly 14.6 pounds per square inch. So that would be pressure, correct? There you go. Just acceleration due to gravity, they say. But this is the issue we have. No one is demonstrating this gravity holding gas down to have gas pressure without containment.
All right. Brenda asks, please give the formal definition of begging the question and use it in a sentence, Flatzoid.
Please use?
Yeah, the begging the question fallacy.
Yeah.
Formal definition and use it in a sentence.
Formal definition, use it in a sentence. Okay, let me quickly get it up. Okay, let's see. Beg the question. The fact of a fact or action raised at a point has not been dealt with. Invite an obvious question. Some definitions mental illness beg the question of what constitutes normal behavior. Assume the truth of an argument or proposition to be proved without arguing. Okay, you beg the question that gravity exists even though it has not been proven or demonstrated at all. Happy?
Right. Leslie from Holy Smalls says, does sodium hexafluoride, which is heavier than normal air, require a full container to be weighed, or does it just need, or does it need to be in a sealed container?
No, you can, anything that's heavier than air is not going to flow over the sides. It's going to displace the air, unless of course you get more of it than that cup can hold. So if it's a heavy gas like carbon dioxide or sodium hexafluoride or whatever, then it's simply going to pour in, and you can measure it with just an open cup. You have to prevent it from flowing over the sides, of course, because it is a fluid. It is a fluid. But
Can I ask you one question on based on that though? If you measure a weight on it now and you wait, let's say 2 hours and go back, would you have the same weight measurement?
Depends on how heavy the gas is and the temperature.
Sulfur hexafluoride.
I need to look up its molecular weight, but it's going to stay around for a while. Of course, eventually, it is going to diffuse into the air, but so what?
So no gravity then. Congratulations.
No, that has nothing to do with there being no gravity. Your
Exactly.
conclusion? No, it doesn't.
This is exactly why I've put up a new challenge, MCToon. I don't know if you've heard it. I've asked Professor Bell to do something, to do this in a vacuum chamber. Get a vacuum chamber and get another container inside it with sulfur hexafluoride, any gas you choose, and then open the partition and see if gravity will hold it down there indefinitely.
Of course not.
So not gravity then.
Oh God.
If there's a pressure differential, then gravity is doing it.
Yeah,
anyway.
that's right.
Flatzoid from Walter Van Bellegum. Gem says, why do you show space behind you whilst not believing in space at all?
Because I still like, as you can see, it's the Millennium Falcon behind me. I'm still a Star Wars fan. I do like space. I just know it's fantasy. Doesn't mean I
All
can't
right.
enjoy it.
We have 2 minutes and 2 questions left. Unless somebody on your chat has something for Leslie. Earth's Life says, Flatzoid, if the container around the Earth cannot be detected by radar, would that mean that there is no container?
No, because we don't know what the container is even made out of. Or we do know we have containment because we are breathing right now.
All right. And then one more from Glober Mom says, a word contains letters and a sentence contains words. Are words and sentences containers?
No, it's false equivalence. But nice try.
And I think I have one more from your chat from Matthew Eastman for Leslie. Does a vacuum require containment?
No. I mean, short answer is no.
All right. Well, we have 45 seconds left, and I'm out of questions.
Well, that was fun.
So what I'm going to do is I'll wrap up with you, and then Leslie and I will I have a few more things to read from my side. But Flatzoid, thank you. That was a well spent Patreon support for the month. I look forward to next month's one-on-one.
Awesome. Thank you very much.
And people in like I said before, if you're in Flatzoid's chat and you're letting me out support him, shame on you.
Okay.
All right.
But it was fun, and I must say you actually did a good job moderating.
I tried. It was
Of course
hard.
he does.
I was biting my lip, man.
I know. So was I.
All right. Well, Flatzoid, do you want to just drop off there, and then
Yeah.
I'll just have myself.
Yeah, I just want to say to Leslie as well, thank you for the debate. Yeah, and thank you for it. Just want to say thank you. It was fun.
Yeah, thanks also, for you did 7 videos about me, and thank you for those as well.
And they're still not finished because the email's not finished. It was a long email. Just haven't got around to them.
All right, well, yeah, continue all you want.
Sure. Thanks, man. Cheers.
Well, all right. Let me do this. There it is. All right. I'll fix this in a second here. But all right, man. He has that religious belief that the container, that the firmament is there.
And yeah, I mean, what am I supposed to say when he says nah to you too? I mean, that's he has no evidence for it at all.
The telling thing is trying to find the there it is. That he really failed on the ideal gas law being applied to the pressure in the atmosphere.
Yeah, it's
right. He
absolutely
right. He didn't. Oh, it doesn't. He's like, you're in a different area, so there's a different volume. No, it's the same. According to your container idea, it's the same container, the same one container. You apply the ideal gas law, you have one V for volume of that container. The pressure should not vary.
Yeah, and well, and he comes up with this very specious thing. It's a system. Okay, it's a system. Yeah, and
it's dynamic.
Woo, yeah, I mean, there are no barriers anywhere in there, no containers anywhere in there, and yet the pressure is different all over the
I
place.
loved the drop of water where that somehow he's like, you're presuming there's no container. Well, no, we don't see a container.
Mm-mm.
It's nothing.
It's, yeah, I mean, it's a drop of water, and it's and he refused to acknowledge or whatever that surface tension is a force that's forcing it into a semi-globular form,
Yeah.
and that gravity is pulling down, which forces it into a teardrop form. Something's pulling down on it, but
Something is. So one thing that the we don't claim, it's often thrown around in caution, without being careful. The vacuum of space. Well, space is not a perfect vacuum. It is a positive pressure system that has lower pressure than here. So we have a certain pressure here and a lower pressure here, and even this amount of vertical space, everybody's smartphone can measure that vertical space pressure differential. And so that's all that it is. You keep going up and the pressure continues to go down. That's all we claim. We don't claim that there is a perfect vacuum. And so how do you demonstrate pressure next to a vacuum? Well, vacuum being lower pressure, easy. Pull out a barometer on your phone right here versus right here. There is the pressure without the pressure differential, which is all we claim, the pressure differential without a physical container.
exactly. There's no place where there is a sudden change.
Yeah, it doesn't go from
in pressure.
14.7 to 0.
No, or even
All right.
It's slightly different the further you go.
All right. Siggy Sigwald came in early and gifted 50 memberships, and Stringer News 1 gifted 10. So thank you for that. And let's see. Siggy then comes and says for 666 ARSs, Leslie versus Flatzoid. Going to be very entertaining. Thanks, Toon, for setting this up. Hail Sagan.
Well, I enjoyed it.
The Grumpy Mechanic says, on the one hand, thousands and thousands of skilled astronomers, physicists, geologists, surveyors, and navigators. On the other hand, this random crank on the internet. The Stringers one, if only this were leading somewhere. Yes. Siggy then says, I'm burning my 4-month milestone super chat to say, gotta light a flurf. Hail Sagan. Did. Everything's a container, apparently.
Yeah.
Everything is a container. There's his lie. Except when something is a container that he doesn't like it to be a container, right? Something is containing the droplet, but what's containing the air pressure differential? Oh, nothing. He doesn't know. He can't explain it. Cygnus Steps says, dude, I have a milestone chat too. Cool. Hugh Jars says, I have a lot of internal gas pressure right now. Doesn't mean there isn't any on the outside of me. There'll be a bit more soon, too. Well done, Hugh.
TMI.
I hope your loved one survived. Caucasian Sensation says, somehow Flatzoid has made being wrong about absolutely everything boring. Normally I get excited to correct a flurf, but information goes in one ear and out the other with this idiot. Toppiest leftiest. Oh. Delco. Delco says, for all three, LaTeX or Tech Live. LaTeX would be the how you often write papers. Or Text Live. So for all three, I don't know what the exact context of that is, but I know that Delcos is working on a paper at the moment, so it's probably neck deep in LaTeX. Earth is Life. Let's see. Oh yeah. So if I already read your question to Flatsoid, I won't reread it again. Delcos says, should rephrase life or what other. It doesn't help. I still don't know. Life or whatever. What other? Sorry, I don't know. Serena's one says can't use Google without a container. Todd Ferguson, Flurfament Technician, says we need to rename Flatzoid. I suggest Summonex. Snore. He does get a little dull, doesn't he? Earth is Life. Let's see. There's why can't it be detected by radar? And he's like, because we don't know anything about it. Well, wait a second. You have said it is a physical container. You've declared that you know something about it. A physical container has physicality. Physicality, right. Things can be identified by radar. But we can't.
Yeah. And infrared and visible light. Don't see anything in any of those.
Yeah, there is no mechanism at all that can detect it. Yet you absolutely, definitely believe with all of the blind faith you have that it exists.
And by the way, with all those meteors that come in hundreds a day, haven't they cracked it?
Yeah, where are they coming from? They just don't like to talk about that. Sierra Lord says Flurfs do not accurate definitions ever. Well, and you know what they do? They take the very first one that agrees with them and think that is the absolute everything to that definition that has ever been presented, right? Never mind that you can study a particular topic for years to at bachelor's, master's, PhD level or past. Never mind all of that. The one sentence definition that they find somewhere is all that they ever need. Let's see. Serena's one, you can't have a horse without putting a cart in front of it. Flatzoid 2023.
I like that one.
Globe Explained said, too flat. Oh, I missed this one. Can your coffee cup, which isn't enclosed, only contain a fluid such as your coffee, or can it also hold gases? Yeah. To the sulfur hexafluoride, some will dissipate. The question that was asked. But the fact that some of it, that just long enough to measure it, something is a force pulling it down. There is a force pulling it down. What is that force? We know what it is. They say nothing is pulling it down. That doesn't work. They just run away from that. All right. Holy Smalls says, Flatzoid, you just cited NASA as correct. That means NASA doesn't lie per you. That is the shape of what is the shape of the Earth per NASA again? Don't think he would like that. He'd call it some sort of fallacy. Wouldn't he? Serena's one says this video requires hip waders. It's getting deep. Yes. So deep.
Did anybody...
Yeah, go ahead.
I'm sorry. I was just going to say, did anybody but me notice that several of his references were meant for children?
Oh, yes. That's the thing. That he finds the first one or only one that agrees with him, sort of, kind of, maybe not, but not really. Yeah. And that's all there is on the topic. That's the entirety of the information on the topic, according to him. Serena's one says, all questions for Flatzoid will be answered by Google instead. Google makes no representation about the quality of these answers. My God, he is the most Google aggressive person I've ever seen. Everything, it just types it into Google. And whatever is the one that agrees with him the most is the one he reads. Unless he didn't pre-read it, then he reads it, and then he's like, oh, crap, that's the wrong answer. Let me think up a fallacy to name it quick, and then go on to cherry pick some other one. That's what, you ever watch him when he does? That's what it's totally what he does. Siggy Sigwell came back with 10 more memberships. Thank you for that. That's 70 new memberships in this stream, and then a chat for 666 ARSs. I had to go buy stuff for dinner, and I missed Flatzoid failing again. I'm sure Leslie did great. Hail Sagan.
Oh, well, thank you.
That is the end of the super chat list. I got about 5 minutes left. What do you thoughts on this?
Well, it's really difficult to not just throw your hands up when somebody is sitting there and lying and saying, nuh-uh, nuh-uh, nuh-uh. And I'm saying that, yeah, but I sorry, Flatzoid, you're just wrong. And he does that continuously. It's a flirt, can I say?
I like this comment from Mark Shire, who's a flurf. Says timeout is a form of fear used to stop truth from getting said. Is that why I'm blocked and get timed out on all the flurf channels? I can't comment on Dearth. I can't comment on Terry R. Eischer. I got timed out in Flatzoid's chat just a little bit ago. So is that what you're talking about there, Mark? But I do tell the mods here, please only time out if they're saying something horrible, right? Like really horrible. I want Mark Shire's idiocy to be forever enshrined in YouTube, both in the right on the screen here, right? So even if you time him out, I do know this stays here, but also please. I want it in the live chat forever. If he's out there saying something incredibly stupid, I want his descendants to look back at that in shame and say, oh, dear God, can we change our name? We don't want to be associated with that person.
Or in the case of Cece, his wife.
Poor guy. Poor lady. She's a trooper.
Apparently, yeah.
Delco says, what flavor of latex does Leslie prefer?
I plead the fifth on that one.
Okay, so latex is for writing, often for writing technical papers.
Yeah.
You don't use they don't use Notepad++, and then just type it out. Actually, you probably could use it to hand edit the source latex. So
yeah, many years ago, I used I think it was latex or something similar, yeah, but it's been a long time.
I think the question would be better directed towards Eric Burns, who already answered in saying, I prefer the overleaf flavor. So I've never directly edited latex. I've read some latex that's been written, but I've never written in this, base level latex, and I've very just fringe actually done anything that ever wound up in latex form. That was actually the fake IEEE document that we manufactured, that we fed to Mark Steele, was done in latex and using the IEEE format. So I should totally try it, says Walter Ben Belligan, who said just call him Q. I use
LibreOffice on Linux if I want to do any kind of graphics of that sort, or special characters and what have you. I use Linux whenever I can.
Yes, I too use a Unix variant all the time on my Mac.
Yeah.
It's nice for work. I mean, I'm at a command line on my Mac, and I just do a SSH to a Linux machine. There you go. And there, Tiny Captain. To your comment, Mark Shire, Tiny Captain was blocked from Flatsoid, from his chat by Flatsoid himself, apparently, for being a merchant sailor that uses a sextant and knows what he's talking about. So Mark Shire, you're right. That was used to prevent the truth from getting out. There it is. Shifty Eyes Shady says I run like 25 virtual machines. If only I had 25 to worry about.
Huh.
We have many, many machines. Many virtual, many physical. Many physical with just one layer of virtual on top of it, so that it can be more portable. Some Docker containers. Oh yeah, it's all over the place. Anyway, so later tonight, people, if you are in for some absolute horrendous torture, we show up again at 10 o'clock Central Time for the Star Wars Holiday Special. I've never gotten more than maybe 20 minutes into it, and I've committed to watching the whole thing. So you people asked for it.
Careful what you ask for.
I like this prosthetic head says, do I still have the 1970 version of Photoshop?
Yeah.
Because all the flurfs think that the 1970s, they claim that the photos from space somehow were CGI in Photoshop even.
Yeah.
So okay. That's all I have. Time to get going. Leslie, thank you very much for challenging him. I think next time I'll probably try to go head to head with him on myself. I'll see if I can. Yeah. I'll muscle it out, people, sometime in July.
There you go.
So, all right, we'll see everybody in a few hours.